So, intermediate. Yeah, that's nice. Yeah, so this will be review for if you guys know the basic syntax. And if you guys have any questions, just put it in chat. Okay, you want to get started?
All right, let's go. So first off, welcome to our first Python basic workshop. First thing what we're going to do is the way that we all will be coding today and working together is via a link that Annie will be putting in the chat. It's called Collaboratory or the Collab notebook. Essentially, it's an easy way for all of us to just get access to a makeshift Jupyter notebook. And for those of you who don't know what a Jupyter notebook is or aren't familiar with another IDE called Anaconda, you can essentially run all of your Python code on those platforms. So Collaboratory is an easier way where you don't have to download anything to get started with coding. So as soon as you open up that link, you can go ahead at the very top left, and there should be a File tab. Go ahead and press that, and you should be, and then go ahead and click New Notebook. So it should take you exactly where you want to be. And then once you've done that, just follow along.
Yeah, so if you guys have any questions, we could also like simulate it as well if you guys have any trouble. And basically, Google Colab is, I'm pretty sure everyone's familiar with Google Docs, Google Slides. And it's like Google Colab is essentially like kind of like a sharing platform for coding. Jupyter Notebook is very popular in Python, especially like practically most education institutions, they use Jupyter Notebook for coding purposes. And you'll see why in just a bit, because it's very helpful. And Google Colab, again, I don't know how much storage they give you for free on Google Colab, but it is free. So we'll be using Google Colab to give you guys some examples. And we also have our Google Colab notes, which I will put in chat as well for you guys to follow.
Awesome. So I'm not seeing any questions in the chat. Then I guess we'll move on. But if you have any questions or any issues along the way, go ahead to send us a message. All right.
Okay, so what is Python? I'm pretty sure everyone knows what Python is, or at least heard of it. Python is a very popular programming language within data science and other fields. It's high level, it's general purpose, it's multi-use, and it focuses on readability. So it's very friendly for beginners, just start out. Yeah, the syntax is obviously more beginner friendly. It's very intuitive. And the best part about Python is that it not only caters for beginners, but a lot of people in advanced and programming, AI, they all use Python because of its wide rangeability. Go next slide, please. And so that's essentially why people use Python. It's easy to understand, and there's tons of libraries in Python. So once you guys get into the more intermediate or advanced side, you guys will find out that you'll be using other people's programs and building on top of their code. So you're not building, like pipelines from scratch. You'll be importing a lot of libraries, and libraries is basically other people's code. And instead of rewriting their stuff, you import their stuff and use their functions. And we'll go into what functions are, methods are, and you can build upon that. So there is a wide range of libraries in Python, and you could do like tons of stuff in Python. You can make all these like elaborate data graphs and just ranging for a lot of data analytics as well. And it takes away the whole like solely logistics part of programming in data analytics. So that's why we decided to have our first workshop on Python. And for you beginners out there, don't be scared. It's fairly easy to pick up as well. And we'll go slow and make sure everyone's on the same page.
Awesome. So let's take a quick look at our collaboratory for today. So first off, welcome. Today, we're just going to be going through the very basics. So the first thing that we want you guys to try out with your own collaboratory and collab notebooks is the print statement. Annie, do you want to take it away from here?
Yes, so basically collab has a very useful kind of tools is that you can see like right above it says plus code plus text. And what's so helpful about that is that you can write code and then have text cells above that to describe your code. And it's very easy. It's very helpful for education purposes. So if you guys could click the plus text, you guys can write your own code. So we did like welcome to Python basics. You guys could also add emojis as well, which is pretty cool. And yeah, we put down our names. And so for code, I think you guys are beginners. I think it's like a tradition for all coders when they first start coding is to print hello world. So I want you guys to just click on the code itself, or you could press Control MB as well. That's kind of like a shortcut. And then type in hello world, print hello world, and press enter, I'm pretty sure. And it should print out and return hello world.
One thing you do want to note is that you will need these quotation marks, either double quotation or single quotation will work. And we'll get into exactly why we use this specific formatting later on. But for now, just follow along.
Yeah, so once you print out hello world, you guys can write whatever you want inside the print functions. You can, you know, like say your deepest thoughts or your visceral feelings over something, and it will return that. So that's kind of the basic premise, like beginners, even non-coders should know this. Print statement returns things in Python.
Awesome. So now let's look at another very common function and a very useful one. It's called the type function. So essentially what it does is if you pass in any, or basically inside of these parentheses, if you put in any value, whether it's a number, some words with a string around, with quotations around it, which we'll get into what that means, and different values on its own, it's going to give you the type of that, whatever element you put into those parentheses. So in this case, we're introducing you to some common data types that we're about to get into in just a quick second. So that's it's a really efficient way for you to know what you are actually using. So sometimes if you get confused or maybe forgot what this 5 really represents, you can easily use the word type and it will give you and print out exactly what it represents, an int or an integer. So these are some common ones that you can do, either with strings, saying true or false, or other numbers. And another thing I want you guys to know is that if you do multiple type functions all at once, it's only going to print out the actual value of the last one. This is true for anything in Python. If you put multiple statements, it's primarily going to carry out the last one if they're all the same function. And this is just because we're not actually printing anything out like we were above here. Printing anything out will make sure that it gets printed in the console, versus here, it's just going to return the last element.
Yes. So if you guys are a bit confused, like what is a bool, what's a flow, we'll just talk right up. But the type function, again, very important. And it helps you understand the types and data types that we'll go over. That's you guys will be very familiar as you guys are still in your programming journey. So let's go back to slides. And so these are the data types. So we'll be going over most of them. And the ones that are kind of boxed in are the most basic data types. So a lot of, basically all programs are built on these data types, and you should be very familiar with them. And you guys are beginners. You guys might, recognize some of these words as well. So the only thing we're not going to go over is complex numbers, simply because it's a beginner course, and coders usually don't use complex numbers. but integers, floats, booleans, and strings are very common. So we'll definitely go over that. And then later on, we'll go on to other more complex data types that are built on to the pre-existing ones. So data types int. So if you guys know what an integer is, please put it in chat. I'm sure you guys do know. If you guys take arithmetic before in class, or you guys are in with math, like integers are any whole numbers. So it's any numbers without dot, without decimal points, without repeating numbers at the end, without variables or i's or cosines. And basically, it's represented as int as a data type in Python. And again, integers use the basic operations as you would in arithmetic. So you guys should be familiar with addition, subtraction, multiplication, and division. So I'm definitely going to go over the kind of two different divisions within Python. There's one backslash and there's two. And the two backslash is actually something that's pretty cool in Python, is that it's floor division. I don't know if you guys know what floor division is, but it divides and rounds to the nearest whole number on the left. And that's also very common in coding, where you don't really want the decimal points, you want to round down. Remainder is represented by the modulus sign, which you can see here is the percent sign, and this is basically gives you the remainder of the division equation. And then the power sign, which is exponents, is represented by 2 star asterisks. And we'll go over some examples as well as see them in action. So again, if you press any number, it's going to return any number. It's Python. What's cool about Python is that you can treat it as a calculator. So if you guys don't have calculators, you could pull up Google Colab and type in 3 plus 3. It will return as a calculator would the answer, which is 6. And you could do with subtraction, multiplication, division. So obviously I'm going to go over those real quick. But the ones I do want to focus on is floor division, which you guys can see 7 floor divided by 2 is 3. Realistically, 7 divided by 2 is 3.5, but with floor division is that it rounds down to the whole number, so it's 3. For modulus, 7% 2 or 7 modulus 2 returns 1, because 7 divided by 2 has a remainder of 1. And for exponents, the left operand raised to the power of the right operand. So it's 7 to the power of 2, which is 49. And for these kind of operations, it's very important to realize the order, especially when you start typing and adding on to itself. So you guys are familiar with pandas. It works the same way in Python. The only thing is that there is some exception. This is the exception with the normal order of operations, is when you print 5 to the power of 2 to the power of 3. I think most of us would intuitively think, oh, it does 5 to the power of 2, and then does the power of 3 on top of that. But actually with Python is that it actually does 2 to the power of 3 and then puts that into 5. So it goes from right to left with order of exponents. But usually with multiplication, divisions, it goes from left to right. And so this is an exception. Just want to let you guys know. You guys can try that yourselves as well. And there's a lot of like practice problems as well from there, but just to let you know, from exponents, it goes from right to left. But again, the whole PEMDAS ordering, the parentheses, Python still follows that.
Awesome. Now so we went over just the common solutions of simple operations that you can do with integers. And now let's take a look at another data type called strings. So strings, this is actually where you will notice that anytime you call a string, you have to use either a single quotation or a double quotation. There's no real difference. And that denotes that the value or the data type that anything you're passing in is a string. So there are different operations that you can do with a string. And remember, a string is just a bunch of sequence of characters. So in this case, B is a character, with I is a character, T is a character, and so on. Two, also, you might be confused. Actually, let me ask you in the chat. What do you guys think? Is this 2 right here an integer or a string, like we've mentioned before? All right, so you guys seem to know what you're saying, because everyone that I've seen so far has said it's a string, and you guys are correct. Anytime you have a quotation around anything at all, it becomes a string. So what we can also do with these strings is a bunch of different operations. So we can do concatenation, finding the length, or even indexing. And let's take a look at a few examples of that. So first off, for strings, one keyword you want to know is, what does immutable mean? So strings are immutable, meaning these objects cannot have their values changed. So if I say the word hello, I can't go back and change the actual string hello to something else. I would have to reassign it in a different way, and we'll get into that later, but these strings are immutable. And at the same time, they're also iterable. An iterable basically means any object that can be looped over or basically iterated over based on the number of characters or elements that it has inside of it. So first off, for concatenation, what you can do is you can just print out hi plus Bob. And if you see in the print statement in the console, it goes ahead and just prints out hi and then Bob. If you say wanted to add a space, there's 2 ways you can do this. Either you can add a comma, which will automatically add in a space. That's a little nice trick with Python. Or you can simply, in the console, when you're printing it out, you can just say add a space right here. Simple as that. So another thing that you can do is you can use different operations like the multiplication symbol. If you say bits times 3, this will automatically print out bits 3 times. And let's take a look at another one. What if we did bits minus 3? So here, there's actually a caveat. So not necessarily, it's not necessarily just going to print out B. Actually, there will be an error. And the reason is, whenever you do, or strings necessarily don't have a operation where you can subtract them. So instead, whenever you want to take away strings from a certain part of it, or you want to take away part of a string, you have to use indexing and different, more advanced skills. But for now, just know that you can't necessarily subtract a string from another. And the main reason is because of the fact that they are immutable. They can't change. So you can't essentially subtract 2 different strings. And the next function that we can look at is the length. And just by typing in LEN, and then with a parentheses, you can put in whatever string you want inside, and it will give you the number of characters that are inside that string has. And another thing we can do is called indexing. So indexing is really cool because you can pull out certain characters from a string itself. So in this case, bits is a string. And what we can say to Python is, hey, please return the second element in bits. But what you guys might be confused with is, shouldn't this print out I? Actually, not necessarily. The way indexing in code and in programming works is it starts off with 0. So the first element here, which is B, has an index of 0. Then I has an index of 1, and then 2 and 3, and so on. So in this case, when we say any string, return the value or element at 2, it's going to give back this T. And notice you want to use these square brackets whenever you're indexing, not parentheses or nothing else along those lines. And the last thing I want to talk about for strings is something that's a nice little trick. Whenever you want to say go from the end of a string and pull out the last few elements, you don't have to iterate through the entire string to find out what the last element is, or even find the entire length first and then go to the end. Another easy way is just saying -1, and that just starts at the very back. So it's going to print out S, and then T is -2, -3, so on. All right. If you have any questions, feel free to put them into the chat. And these were all of the different operations that we've talked about.
Okay, so next we'll be going on to floats. And what floats are is that they, instead of integers, they represent real numbers. So do you guys remember what a real number is? Put in the chat if you guys know what's the difference between a real number and a rational number, if you guys still remember. Yeah, it's pretty tough. It's not fake. That is very insightful, yes. Real number pushing. So guys, what is the real number? Like, we know 2.8654321 is a real number. But do we know like the definition of a real number and what's the difference between a rational number? So real numbers is any number that is found within the number line, continuous number plane. So you guys know from negative infinity to infinity, it's like a bunch of numbers. If the number exists within that line, that continuous line, it's a real number. So would you guys consider pi as a real number? Yes, because it's technically found within the continuous number line. So this does not include any complex numbers, any i's, any square root of -1s. And the difference between a real number and a rational number is that rational numbers are technically a subset of real numbers. And floats include rational numbers in that they include any number that has integers divided by another integer, and that's a rational number. And real numbers is just any number that does not have any complex variables or anything that's found in a number line. And so this includes decimal points. This includes 2.3 to the power of 10/3. And so again, with this, like all of the operations are the same, just like in mathematics. It's just a bit more complicated. So yeah, let's go back to the Google Colab and see some examples. Again, any real number that exists within a continuous number line is a float. So 97.98 is a float. Again, addition, subtraction, multiplication, division works. And so as you scroll down, you'll see that the interesting thing about dividing or subtracting with floats is that it returns an answer that is a float. So no matter you do like 20 operations, if one of them is a float, it will return a float as an answer. So when you print 7.23 float divided by 2, even though it returns a whole number, it returns it in float form. So it returns it with 0.0. And then with modulus the same, and with exponents the same as well. And so that's the thing I want you guys to get from floats is that, yes, it works basically with integers. And if you put them in some equations, it will turn the answer in float form, in decimal form, with the 0.0 even if it's a whole number.
All right, so these are some other practice problems that you guys can look at, and we have the solutions right there in front of you. And feel free to practice more if you want to. So now let's go ahead and take a look at our last basic data type that we're going to be talking about, which is a Boolean. Essentially, Booleans are either a true or false value, and the only examples for them are true or false. Essentially, what they do is they're really helpful in letting us figuring out some more complicated functions and figuring out if some long expression, say, some long expression in general, if that actually comes out to true, then we can do something with that. Or if it turns out to be false, then we can do something else. So they're really handy, and we'll get into more examples with them later. But for now, what we can do is we can use different operators, such as the and, or even the not. So let's take a look at some examples. First off, to actually print out true or false, you can just type the word in, but make sure to have a capital either T or F based on the word. And another thing I would want to mention is checking if something is true. The way to do that is by using a double equal sign. So that essentially is a conditional statement that says if the right-hand side is equal to the left-hand side, then return true. So in this case, since 3 is equal to 3, that is true. On the other hand, 2 times 5, as we all know, is 15. Oh, sorry, is 2 times 5 is 10. That's why it is equal to 15. Is that true? Not necessarily, right? So that's why it's false. Another thing we can do is use the or operator. So we can check if true or false, which one should it evaluate to. So if you have either true or false, it comes out to true. And the way you can denote an or symbol is just by typing the word. On top of that, you can also type in the word and to find out whether true and false is all in all a true statement, but that actually turns out to be false. And lastly, another thing we can do is using the not symbol, which is represented with an exclamation symbol. So 5, is that equal to 3? Not necessarily. So if we say 5 not equal to 3, that's actually going to be true. So these are some useful operators that you can use when you're trying to work with Booleans. All right. This is another, this is another slide that you can look at if you want to get more interested and would like to figure out a little bit more about Booleans and how they operate, but we're going to move on for now.
Yeah, so just from that previous slide, if you guys are planning to take discrete structures or logic, that's very important. It's like saying, well, true and false, what does that make? It makes false, etc. So we don't have much time, but obviously that's just the table that you would use, and it's very important for coding, especially the logic. So data types, this is basically a summary. This is everything we've talked about. As you can see, the common operations, examples, kinds of values. And so we'll be moving on, so because we don't have much time.
Awesome. So let's take a look at another thing in Python, which is called variables. So essentially, if you have a value that or some piece of data that you want to keep reusing, one thing you can do is you can use variables. And essentially, they're containers that hold onto that value, and you can change that value anytime you need. So pretend you have a box. Inside of that box, you can put anything you want inside, and then let that box equal to some string or some value itself. So let's take a look at a few examples in a second. But essentially, you can set anything equal to any word equal to a variable that represents a variable, and then we can use it later on. And the way to assign a variable is using this equal operator. Before we looked at the equal conditional statement. However, now we're only going to be using the equal symbol, and that primarily just assigns any value to something else. So let's take a look at a few examples. First off, for variables, you can use anything. Here we have x. So x is equal to 1. And now whenever you recall x, it's going to print out the value that we initially stored, which is 1. So if we now replace this value of x with hello, which is a string, if we go ahead and try to call x again, it's actually going to print out hello, not 1 anymore. So it changes the value based on how you reassign the variables every time. So another thing that I wanted to talk about was the difference between how you can name a variable. So one is camel case, and the other doesn't have a proper name, but it's just generally known as the underscore naming method. So what you can do is with camel case, you take the first word and you leave it as it is. And the next word, just the first letter of that word is capitalized, and then so on. So this, and then is with a capital I, camel with a capital C, and a case with a capital C. And the underscoring naming way is just to split every word with a simple underscore symbol. So one other thing that we can do is we can say I have a cat and that cat's age is 7 years old. So I can set this variable equal to a string and then print out this string plus this variable that I had assigned. So it's going to go ahead and give us the fact that my cat is 7 years old. Another thing you can do is you can also print out numbers or set numbers, floats, anything you want into a variable itself. So this float, which is the first few digits of pi to the power of 2, and we can set that value all into this variable. And then when we print out my float, it's actually going to give us this new value. So that's a little bit about variables. If you have any questions, feel free to ask them in the chat.
Okay, so now we'll be going to some more complex data types. Yeah, so I'll be doing lists and tuples and data type list. So you guys think of list, you think of like, okay, my grocery list. And what is that? It's basically like a sequence of values. That's the kind of programming term. And so for Python, it can intake basically any type of value. It takes strings, chars, ints, floats, just everything we've viewed from before, the basic data types. And it can also take lists, which then you could do like some inception moves and make, you know, nested lists, which is something I'm going to really be talking about. So examples, basically it's all the data types are kind of contained in a square bracket and it's separated by commas. So you can see hello, 4C, 4.99 are values inside the list. And some useful operations, things that you can do with the list is that you can append, extend, insert, and remove. And so we'll show you how that works in Google Colab. Again, sometimes you want an empty list. And so in order to instantiate an empty list, in order to create one, you just do square brackets and returns an empty list. Usually with lists, you do like numbers inside. So again, if you want to put something in your list, make sure to separate them with commas. So you can see here, this list contains 10, 20, and 30. And this is something that's very unique to Python and makes Python incredibly flexible and beginner friendly. It can hold different types of values. So you don't have to say, okay, this is going to be a list of numbers. You can just write random list, or you can write anything and put whatever values you want in. So obviously this random list contains both numbers, strings, and booleans. And again, Python does not crash. It accepts that as a valid list. So the crazy part about lists, especially, is nested lists. And the reason why I want to show you this is that the nested list is different in lists, in that even though it has the same values from the human eye, you can see it's 10, 20, 30. The nested list is actually a list of lists. Each list has one data type, which is an integer. And so it is different from the original list from the 2 cells above, in that it's contained of lists. And obviously you could put more values inside a list, and it's endless. So you can make nested on nested on nested lists on top of that. So as you can see here, random nested lists. So this is a list, like this is basically what flexibility of Python allows you to do. It basically allows you to create tons of lists, and it can get confusing, which is why you won't really see this kind of randomized format. But I just wanted to show you how incredible Python can be and its flexibility. So as you can see, there is a bunch of lists inside one. I wonder if you guys can tell how many values there are inside of that random list. Does anyone know how to see how many values are actually inside of the random nested list? You guys can take a guess. Don't be afraid to be wrong. I just wanted to see if you guys can kind of differentiate the amount of actual values inside of it. And here's a hint, like inside the list, there is more nested lists, but it counts as one value. So how many values do you guys think is within the actual random nested list? Okay, good job, guys. Shout out to Ava. So yes, there's only 2 values, and you look at this and you're like, how is that 2 values? Basically, you can tell by if you go from inside and outwards. So the skr 79 is one list, but it's nested inside another list that has scree, and it's nested inside another list as L plus ratio and P3, P3, P4. And that's when it has a comma, and then it has another value 99.9. So there's actually only two values. The first one is this huge, gigantic blob of randomness list. And the second is an integer, 999. And as you can see, it's very complicated. And usually in programming, you don't do this kind of stuff, but it's important why in future to organize your code and make sure that it's easy and developable as well. So as you can see, I printed out the length of lists. And again, length function could also be used for lists. So you could print it out, and instead of counting and finding out the square brackets, you can essentially use the length function. I also want to shout out that you can turn a string into a list as well by using the list function. And then again, lists are iterable, so you can go through them kind of like a file. So again, I print out all the lists using index. And basically, if you guys don't know what index is, it's like the position. So instead of referring, your value of like pineapples in your list as pineapple, you refer it to, like it's the first thing on my list. And so for programming, the index is the position, and it starts at 0. It does not start at 1. So your first item is index 0. Your second item is index 1, etc., etc. And it ends with length of list minus 1 because naturally your index is 1 before your actual number. So as you can see, you can print out all your lists and select one of them, and then you could also print out the reverse of your list through negatives. And this is basically saying, well, the last one on your list is -1, and the second to last is -2. It's second, third to last is -3. And so here's some common operations. So from lists, you could use, these are basically the most common ones. I mean, you can kind of see intuitively what they would do. Appends and extends. Appends, the difference between them is that appends entire list as one element to the original. So you take A, which is this whole list, and then you append another list. And what it does is, as you can see from the output, it just appends it as one element in the original list. And what extends does is that it says, okay, no, I don't want my list to be inside another list. I want my values from whatever my list to go into the original list. And what that does is that it appends all the values instead of the list itself as values within the original. And what inserts does is that it inserts any value as at any sort of index. So you put in your parameters, which is like the stuff that goes into your function, your index first, and then whatever number. So indexing, you put 3, it puts 3.5 at position or index 3, which kicks out 4. And so it's 1, 2, 3, 3.5, 4. And be careful because it can go out of bounds. So if you said, oh, I want to put it at index 9,000, well, there's no 9,000 index in this small list, so it will turn out of bounds. And for removes an element, it's kind of the same, except for this, it's kind of different parameters. You remove the object itself instead of the index. So you say, okay, I want to remove 9. I don't want 9 in my D list. So it basically goes through your list in order and says, finds the first 9 and removes it. If 9 is duplicated, it removes the first 9 and then it stops. And if 9 isn't within the list, it returns the original list and removes nothing, which is great.
All right, so let's go on to another data type, which is personally one of my favorites. It's called a dictionary. So dictionary actually can hold a bunch of different values, but the most important part about it is that it needs a key value pair. So if you look at the examples that are given, you have first a string, math, and then right after it, you see a colon. with followed by an integer here, which is 27. And this same pattern follows. So what you want to do is you always want this colon right here, which what it does is it associates the string on the right or on the left right now, which is math, with the integer 27. And you want to make sure to use these curly braces in order to denote that you're using a dictionary. So there's a bunch of different operations that you can do with dictionaries itself. Either you can get the values, update it, get different values itself, or even pop out certain key value pairs. So let's take a look at a few examples. First off, for a dictionary, we can just create any dictionary, again, with our curly brace and our colon. And let's look at a specific dictionary right here. So this dictionary has apples, which are apples, mangoes, and dragon fruit. All of these strings are paired with another integer. So remember, these are keys all over here. So keys are the apples, mangoes, and dragon fruit. And then all of the values are everything that's to the right of the colon. So all of the numbers. And if we want to go ahead and grab all of these keys, we can just say my dictionary dot keys with a parentheses symbol. And what Python does is it's going to give you a list of all of the different keys that are in this dictionary here. That's really cool. One thing we can also do is obviously get the values. If you can get the keys, let's go ahead and get the values. So again, just do dot values with the parentheses, and it will give you another list of all of the values. From there, if you want to say get a specific value from a certain key, what you can do is you can do two different things. To get certain values, you can either use the square brackets and just say the key that you're looking for. So in this case, apples with either a single quote or a double quote would not matter. Will still give you the integer, which is 1.59, which is associated and which is the value that is associated with apples. And another way you can do this is to use the .get method. And essentially what it does is it will again give you the same result. So these are two different ways that you can get different values that are associated with different keys. Another thing that dictionaries are really cool about is you can update specific values. So say one day mangoes really became really expensive. There was a huge scarcity of mangoes. So now their price is no longer $5.99 like before, it's $20.99. So what you can do is you can use the assignment operator equal and just set that value for our key. So whenever you now print out key of mango using our dictionary here, you will immediately get out the 20.99 instead of just 5.99, which we had before. And another thing you can do is you can actually add values with the update function. So say you had a new fruit in the market that you wanted to add to your dictionary. So you can set a variable called new fruit equal to a dictionary of that new element that you want to add. And you can simply then use the .update function. And what it does is it's just going to add it into our dictionary at the very end. So as you can see right there we have the next fruit. And then another thing that dictionaries are really cool about is that you can actually put anything you want into a dictionary, especially in the value position. So here we have numbers, we have strings at the second element. Then you can also have strings. In fact, you can even have a whole dictionary inside of another dictionary. So technically a nested dictionary. So here, if I wanted to say print out the value associated with the key list, it's going to give me the entire list. What I can also do is print out the dictionary. So just by putting in this key over here gives me the entire dictionary. And if I wanted, I can actually get a specific item in the nested dictionary itself. So if I wanted to say print out nested, what I can say is the first key, which is dictionary, and inside I have another set of keys that I can look at. So either I can say key 1 or key 2, and it would, since I said key 2, it's going to give back the word nested. And if this was anything else, it would again give back that value. So another thing we can do with dictionaries, which is really cool, is you can actually remove elements directly. So by just using the .pop method, we can go ahead and take away any element that we want. So say I want to take away strings from my cool dictionary, it's going to go ahead and take that away. So now when I print out my cool dictionary again, Notice that there's no string element or no key or value that represents string or woe. Now say we did this again and we took away this dictionary, again, with the .pop method, it's going to take that away. There are some restrictions, however. So actually with a dictionary, since these keys must be of mutable types, such as strings, numbers, or tuples, we can actually put different values for your keys here. They don't necessarily have to be strings. So if you want, I can actually put an integer here. So if I say 3 is my key, and then I try to get the key 3, it's actually going to give back 7. At the same time, though, since lists are not mutable, we cannot use a list here. It's actually going to result with an error if I try to create a dictionary with a list as our first key. And you also at the same time cannot use a dictionary. So here you want to make sure that you're using all immutable types, which would be strings, numbers, or tuples, for example. So dictionaries and lists per se don't necessarily work if you're trying to associate with a key here.
Okay, so back to tuples. Tuples are something that you probably may not have heard of. It works the same as strings in that it saves a sequence of values into kind of one data type, and it takes the same values as strings, as you can see, and it has limited operations as a list. And the reason why is that tuples is what Python does is there's limited capacity and flexibility with the list. So as you can see from before, lists is like you could do random stuff. You could make it incredibly crazy and flexible. You could change the values. And tuples, it's not the same. Tuples is okay, you create them, it's done, you cannot change it, it's permanent. So the operations that you could do with a tuple is fairly limited. It still has its uses, is that in that, some values you don't want it to be changed. You don't want someone to go into your program, start changing the values. And if they're static values, you want it to remain static. And so that's what tuples are used for. So as you can see in our Google Colab, with empty tuples, there's 2 ways of instantiating an empty tuple. You could just do parentheses, or you could tuple parentheses, which both creates an empty tuple. And if you want to put values in it, there's different ways. So there's the first way, which is, same way as a list, is that instead of putting square brackets, you put in parentheses, 1, 2, 3, it prints out 1, 2, 3 as a tuple. And the second way is kind of what most people do, is that you don't need the parentheses. Python recognizes that as a tuple and says, you know what, you're giving me multiple values. I know it's a tuple, and it prints out a tuple instead. So yes, both ways work, and both ways produces the same result. So obviously there's something kind of quirky about Python, is that because of its flexibility, it can lead to a lot of misunderstanding. So with tuple1, it's in parentheses, it's in a string. Michael, is this a tuple or a string? Do you think Python will say this, okay, this is a string, or recognize it as a tuple? So you guys can guess if you like in the chat. Yeah, wrong answers, right answers. Just guess, what do you guys think intuitively Python should print out and recognize it as? Okay. So we have a guess for string, we have a guess for tuple, we have a guess for string. Okay, so it looks kind of confusing. It's in a parentheses, which is a tuple, but also quotation marks, which is a string. It actually prints out as a string. So the thing is, with Python is that it sees the parentheses and it sees the quotation marks, but it does not see the comma at the end. And it thinks, okay, it's a string. So yes, when I first saw this, I thought, oh my God, that's a tuple. But no, in Python, it's actually a string. So if you scroll down a bit, yeah, so tuple one, if you want to instantiate a tuple with one value, you must add the comma at the end. And that is the weird thing. If you don't add the comma at the end, it's going to mistake it as a string. It's going to print out as a type of string. This is just a little quirk in Python. Usually in tuples, you either instantiate an empty one or you instantiate one that has values in it. But again, just noted for one values, make sure to add the comma at the end. Again, so we kind of did some hacks with trying to accept, and that's something in Python. You could try a line if it has some sort of error, you can print it out without crashing the program. So what we decided to do is we decided to try, okay, can we change the value? So we're trying to change 7 into a fish. And except that we can't. So it displays a type error and it returns tuple object does not support item assignment. And this is because you cannot change any values into any fish or anything for that matter. And the values remain static all the way through. Again, with tuples, you can do the same thing with lists. It's iterable, so that means you can find specific values using index, do the reverse as well. So it's fairly the same as a list. And then comparing tuples. So you can compare tuples, and the way it compares is that it takes the first position and sees, okay, is 2 smaller than 3? And if it is, it returns true. So it always compares the first position, and if different numbers, it just returns the result of that number. It does not look further. If the numbers are the same, then it goes to the next position, which is 3 and 5. So does it check, was 3 smaller than 5? It's yes, then it prints out true. And in the end, it goes through the entire thing. So if your tuples have the same numbers all around, it's going to print as true. It equals to the other tuple. So that's how it compares tuples. And then for tuples, something you'd want to do is maybe see the minimum or maximum value of the tuple. Instead of counting or sorting through yourself, Python has this neat function where you could just type min parentheses and put your tuple inside as the parameter, and then it will basically find out the minimum and maximum values. And then trying listing tuples. Sometimes you want your tuples to be lists, and sometimes you want your list to be tuples. So as you can see, we have a wannabe tuple, which clearly a list because it has square brackets, but it wants to be a tuple. So we can give tuple list status. Give list tuple status by having achieved tuple status tuple, and then using the tuple function and putting that list inside that tuple function, and it will turn achieved tuple status tuple into a tuple. So the type would be a tuple, and the same thing works in reverse. You could use the list function to turn tuples into lists. So a wannabe list, which is actually a tuple, could go through the same process and become a list. So that's something neat in Python. Yeah, I just want you guys to know.
All right, also it is 8:30, so if any of you have to leave, we totally understand, but we will keep continuing because there's a few other topics that we want to get to, so feel free to stay on and learn some more.
All right. Apologies with how long it is, yeah, but they're really happy if you guys stay.
All right, so let's look at our last data type for today. It's a set. So sets, again, we're going to use our curly braces, but this time it's a little different from dictionaries because they don't have key value pairs. So in a set, you can put different elements into it. separated by a comma, and it's just you can put a string, integer, anything you really want, and denote that as your set. So these are also mutable, and some things you can do is you can combine sets. So you can use the intersection, unions, or difference functions to do certain functionality. So let's take a look at a few examples. First off, for sets, they're unordered and they're also immutable, so mutable, and they also have unique values on its own. So in this case, we see 1, 2, 3, 4. That's great, that's a set. But now in this case, if we had a really complicated set that looks something like this, which had a lot of duplicate values, if we go ahead and cast this into a set using our curly braces, what we will see is that when we print this out, it's actually just going to print out one copy of all of these elements. So now if we take a look at, say, another set, again, it's going to print out one copy of each of these elements. And one thing you might notice or be wondering is, why does this not print out in order? It's mainly just because sets itself are not an ordered set of unique values, so it's unordered. In this case, it doesn't matter that the 2 is less than 32 or even 51 or anything along those lines. It's just going to print out one copy of any element that's inside of this set here. So one thing you can also do is use the dot intersection method. And what it essentially does is, say you have one set here and another set here, you can use those and see what values do they have in common, which in this case is just 2. Another function that you can use is the dot union. And what it's going to do is it's going to result in a set that has one copy of every type of value in both of these sets. So it's essentially going to combine the two sets. If there's any duplicates, it's just going to, again, print out one copy of that. And another thing you can do is use the dot difference to essentially figure out what the sets don't have in common. So in this case, it's practically the opposite of the intersection. So what both of these sets don't have in common will be resulted. So that's a little bit about sets for now. If you guys have any questions, go ahead to type in the chat and ask about any of the data types that we've talked about so far. Awesome. So let's take a look at some conditional statements now. So first off, these are essentially a control flow. They control execution flow. And one that you might have heard of is an if statement. So if I tell you to do something, then there's a chance that you will do it. So what we can do is in Python, if I'm teaching you today, then you are learning. So by using these associated keys, what we can do is set actually these conditional statements in Python and get Python to also follow what we want it to do. So specifically with if, that's the first block of code that actually gets executed if a certain condition is satisfied. So either using a parentheses, you can denote what you want that if loop to do. And if that is not true, and this is where Booleans come into play, if that is not true, then you can use an else if statement, also known as an elif in Python. So this basically will be executed, as you can see in the image, if this if loop is not true. So if the location is not equal to park, which pretend we don't know the value of location, if it's not equal to, it's going to go into the elif conditional statement. And it's going to check if it's equal to mul. And if that's also not true, it's going to go into the else. And this is essentially the last check that we are doing in this case. And we're saying if none of the other if conditions were true, or else if conditions were true, then go ahead and print out the last line here. And this can be anything. It doesn't all have to be print statements. You can do addition, subtraction, change values, whatever you really want to do. So let's take a look at a few examples of if statements. So for in this case, one thing to always remember is that for any if conditional statement, you need to use a colon after your first if and condition statement that you set. And then the next thing is to make sure to have an indentation for whatever you want to be inside of this loop. So in this case, this if statement has a print condition, or has a print statement that will be outputted if x is not equal to 2. And you want to make sure that this is actually indented. So it will go through and figure out the actual what if x is equal to 2 or not, and then it's going to print out that it is equal to 2 based on our code here. Another thing we can do is use an elif right here. So else if, and again, it goes right after the if and right before the else. And in this case, since x is equal to 3, it's going to print out the first statement, which is it works. Now, one thing I want you to do is take a look at this code here. There's a lot going on, but go ahead and tell me there are 2 things that are wrong with this code. Tell me if you can find any one of them. Let's see. All right, so I'm seeing the indentation and a missing colon comment. And that's true, both of you are correct. So in this case, there's no colon here after the actual condition. And also there's no indentation for the print. So there will be an error. But if we, again, copy this code down and reformatted it, then there, as you can see, it works. So let's look at, that was everything for if condition statements. So now let's go ahead and move on to another form of conditional statements, which in this case, we're just going to go over quick operators. So if you want to say if something is equal, you have to use the double equals sign. We already talked about that. Another one is less than. So it's the less than symbol. Greater than is the greater than symbol. Not, again, remember, is the exclamation point. So not equals is represented by the exclamation and then the equal symbol. So from there, if you want to say less than or equal to, use the less than symbol and then equal sign and then the reverse for the greater. So greater than symbol and then the equal sign. Note the greater than or less than symbol have to come first before the equal symbol itself. So again, if in your if statements, you want to say compare if 3 is less than 5 or 3 is not equal to 5, anything that you want, you can use these operators here and they'll help you write your statements.
Okay, so now we're gonna go to for loops, and for loops helps you iterate over sequences. So you don't have to write print 20 times. You could say, hey, listen, I want to print this many times instead of you physically writing print blah, 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 print blah, blah. And doing that is called hard coding. And that's not what we want to do. We want to automate as many processes as we can. So there's 2 different types of loops that are very popular. First loop is iterating over sequences over like a certain amount of times. So again, we talked about iterations before. You can iterate through strings, lists, tuples, and so you can see you could also use the range statement, which also iterates. And the second one is while loops. And the difference between while and for loops is that while loops executes infinitely until there is a condition. So let's say you want this to execute infinitely until the next time it rains. You don't know what time, you don't know how many times you would have to execute until it rains. So you say, you put like a condition, and this is where Boolean comes into play. So you put a condition where if it meets, then it stops and does what you need to do. And the problem with while loops is that it can result in infinite loops. So you have to be careful the condition ends up being met some way or other, or else it'll turn to an infinite loop, which will break down your program. So again, loops iterates over a certain amount of times. I just want to say you could use the range function, which is basically given a range, prints out x. I want to say that the first number of the range is the starting point, and that is inclusive, but the second number, which is 6, is non-inclusive. So in this case, it prints from 0 to 5, but you still see it prints out 6 times. It does not include the last number of ranges. So another example for loops is that you could use it to iterate through tuples or lists. In this case, we have a tuple of some common fruits, and we say, okay, I want you to go through all of the tuples for now, the fruits. So again, it works like that as well. Great thing is that you can start building code and start building more complex programs. So if you can combine loops and conditional statements, you could iterate through them, but like, what's the point? If we want to find a specific value inside the list. So we could have a through list, have a loop, for loop, and then inside the for loop, make sure it indent, but you can have a conditional statement say, okay, if X at this time is a banana, I want you to break the loop because we already found what we're looking for. So in this case, X is the first item. It's at index 0, it's fruit. And so it prints out apple. X is not a banana because X is apple. And so it goes on to the next iteration. Next iteration is banana. So in that case, X becomes banana. So X is the iterator and it goes through all of those loops. Again, the break basically says, hey, listen, we've already found what we're looking for. We're tired of this for loop. We want a break. And so it completely stops the loop after the comparison. I just want to let you know that the position or which lines you decide to put before others makes a huge impact on the type of things that outputs. So in this case, the print statement is after the condition. So in this case, it prints out apple because in the first scenario, X is apple, prints out apple. But in the second case, the condition comes before the print statement. And so it fulfills the condition and it breaks. And then break loop basically says, ignore everything else, ignore anything about the loop. We're going to exit out of the loop. So it does not include the print statement. And so it breaks the loop before the function print can be executed. So be mindful of the kind of logic. It's very important to go through step by step because machines can't understand humans the way we do. And it's very important to get the logistics right. So while loops, again, it's same concept as for loops, except you need something that fulfills the criteria. So in this case, this prints out the same as the for loop before. You could do while X is smaller than 6, print this, but make sure that you have some way that X reaches the criteria. So in this case, we're adding 1 to it. So X plus equals 1, you could do X equals X plus 1. This is just a shortcut. And if this line did not exist, X remains 0. And so if it results in an infinite loop, and what happens is that your program will just spam prints X over and over and over and over and again. And then eventually your computer gives up and crashes. So make sure you have that kind of condition. Any sort of iteration makes the while loop stop. So we're going to introduce continue, and continue basically skips the iteration to the next. So we're going to use a while loop, and while I is smaller than 6, I increments I plus equals 1, and if I equals 3, it continues. And what that does is that it skips the iteration. So it skips everything that comes below the continuous, anything that comes below the condition, but it doesn't break. The difference between breaking and continuing is that breaking says, okay, I give up this loop forever. I'm saying no to the entire while statement. I don't care how many I's are left. I don't care if it's fulfilled or not. I'm breaking. Continue just says, hey, we're just gonna continue on to the next I. We're gonna stop and we're gonna continue to the next iteration. We're not done with this yet. We're just stopping at that value. So in this case, when I equals 3, it continues, ignores the print function, but it still continues in the fact that I becomes 4, and then it goes again until it reaches I 6. So it does not break completely. If we had break instead of continue, it would have broke the for loop, and then while loop, and then 4, 5, 6 would not have been printed at all.
All right, and now let's move on to one of the last topics for today, which is functions. Essentially, say you wanted to do some functionality over and over again, maybe 10 times, 100 times, 1,000 times. There's no need for us as programmers to keep rewriting that piece of code again and again and again. Instead, it's a lot easier for us to use a function that we can recall multiple times. So one thing that you can do is use these functions, and inside of it, put different functionality that you want to happen. And then anytime, like you can see here, this is even function is in blue. That's the name of this function. And we can call it again later by just saying its name with the parentheses. So now let's take a look at a few examples of functions. So first off, the syntax for let's go back. So first off, the syntax for a function itself is the def keyword. You need to have that. So it's spelled DEF. And then the name of any function that you want, followed by parentheses. And again, we see this colon one more time. And after that, you need to indent everything else afterwards, and that's where your code would go. So in this case, your first function, to write that, just follow the syntax. And if you run this next time in the next cell, you'll see that if you say the name of that function along with the parentheses, it's going to print out exactly what we want it to. So if we say did this 10 times again and again, just by calling this function, it's going to print out, does this print 10 times? So feel free to practice with that a little bit on your own. Now let's take a look at a little bit more complex functions. So these are using parameters. What we can do is say we want the user, or say you, or anyone really, to define a certain type of parameter. And we want to use that in our code. So what we can do is when we're actually calling that function, we can put in a value inside of it. So in this case, magic. And this is now basically in Python, this variable called my parameter is going to be assigned to this data, which is the string magic. And now whenever we print out our my parameter, this variable, it's actually going to print out magic right away. So that's a really cool feature. And in the future, if you want to reuse parameters and execute some really cool functionality with it, it allows you to do so. So let's take a look at another case where you can use multiple parameters. In this case, you have S1 and S2. And what you can say is call the cool function and type in the exact number of elements that you have that are separated by a comma. And then it's going to set hi, the string, equal to S1, and S2 equal to Sam with an exclamation mark. And then it's going to return out the S1 plus a space, which is denoted by right here, and then plus S2. So now you can see the hi, hi Sam. Another thing here is, if you notice, in this case, there is, if you say run this print or run this piece of code right here, there's an error. So I want to ask if any of you guys know why this is an error right here? This is the function that we're referring to, and this is the function call that we wrote up, but there's an error. Any clue why? All right, yeah. So someone in the chat said, actually in the chat said missing S3. So yeah, sort of. In this case, actually, where we only have two positional arguments that we're telling Python and this function to actually accept. So since this only accepts two different values, we're actually passing in three. So either, there are two ways to fix this. Either we add in an S3 or some other variable name, say hello. It doesn't really matter. It can be anything. And we can pass that in, and now this method call would work because now we have three different positional arguments. Otherwise, if we don't, this is going to remain as an error. So you're correct, actually. And now let's take a look at one other quick thing. You can actually set the result of this function call into a statement and then print that out as well. So there's a lot of cool things that you can do with functions. In fact, if you want, you can do some more complicated work. So if you want to check for evens, this is a little piece of code that you can check if some list that was provided right over here as a parameter has an even element inside, and then it would return out either a Boolean true or false. And then from there, this is, I believe, one of the last things for today, but go ahead and tell me what's the error right here. This is, I'll leave it up to here so you can see the actual function. But any guesses on what the error is when we're calling check even? Here we have a list, we're passing in a parameter. but still there seems to have some error. Any questions? Or any thoughts? That's okay. This is a tricky question. So actually the reason is, in this case, is 1, 2, 1, 1, 2 a list? Actually, right now, it's just a collection of different integers that are separated by a comma. So in this case, this actually is not representing a list. And what Python sees is that this is 3 different arguments, 1, followed by another integer 1, followed by another integer 2. So this list that we are expecting actually is not represented correctly. Correct way to represent it is by having the square brackets. And then if we run this, it's going to go ahead and print out true. So now let's just do some reviewing and let's see what you guys think.
Yeah, so I think one of the most important things when you start programming is repetition. Programming is not like a sport that you could just watch. It's something that you definitely need to try for yourselves and experiment. The more you kind of work around with Python, the more familiar you are at it. And it's very important that you get these core ideas, these core data types, functions, for loops and conditional statements like down. So again, the best thing I would say is review, test these out. So like, write down some nested lists, just look at it, play around with the program. That's what Python is for, and that's how you really understand things. Is that when you get into these errors and find them out, that you understand more about how it works and the way it works. So best way to do this is kind of test your understanding. Obviously, we did a broad scope and overview of the data types, but we did find a lot of things about slicing that we didn't talk about strings. So this is not like the NOBO for beginner programs. This is definitely an overview, but we definitely suggest you to look deeper into it and practice some of this stuff. There's a lot of free resources out there. The best way is kind of reviewing. So obviously, we did talk about random nested lists before. I think that was kind of like the more complicated stuff that we talked about. So obviously reintroducing nested lists. Nested list is anything that has this inside of itself. And so here's like a more kind of complicated nested list that you can find. The one that I had an example before was more or less similar. So as you can see, nested list here, completely random nested. Usually though, you'd have nested lists of the same equal size and you wouldn't have nested lists inside nested lists. But again, Python is very flexible. And then bottom we have a review question. So obviously we bring back the famous random nested list again, and we're asking which of these values are P3, P3, G4. If not, what is it print? And so we had a bunch of indexing, so you guys can look at them yourselves, kind of see, okay, which one is actually prints out the value. And this is kind of testing your knowledge and idea of indexing and positions. So yeah, take a minute and see which of these print the following value. Yeah, we'll wait for someone who has an answer. You don't have to look at the bottom options. You could just, write it yourself. But obviously, if you're new to this, then definitely these are nice guidelines. And then later we will have the answers and kind of explain more about indexing as well. So does anyone know how would you reference the value? If not, 1, 5. Okay, so you're brave guess 1. Okay. So we'll give a few more seconds for anyone else who wants to try this.
All right, I believe Annie is connecting back.
Sorry about that. I'm in the quads. So the first one, I think a lot of you guys have guessed the first one. If you can see, the first one actually is not the right answer. And the reason why is that it references the first object, the first value, and the first value is this nested list. So it's not exactly the value that we're looking for, but it contains it. It does contain it, so it is on the right track. It's not exactly the one that we're looking for. And so this goes into like your understanding of indexing. So the next one, again, it references it builds upon the first answer, and it references the second position, which is the second value, except the second value is again L plus ratio. It's not the one we're looking for, so no, the second one isn't the right answer. It prints out L plus ratio. The third one, again, it's going off track. It's kind of saying, okay, the value must be inside the nested loop. Sorry, not nested list. And in fact, this is not the case. You're going to enjoy it, and you're instead printing something that that's not within the nested list. And the fourth one, again, no, it's printing the second position of the nested list. And again, it's going too far into it. But this is, again, like kind of the examples of how Python can kind of get a little bit complicated. So the fifth one, which is kind of the second one, and the reason why the second one is a bit off, it's just a different position. The position of P3, G4 is actually in the third index. Third item. So it's the second index. And so the actual answer is 5. The fifth one, and it's randomness list 0, 2, and that actually prints out P3, G4. So obviously, this is just like a question that we made up on the spot, but it definitely helps you test your understanding of indexing with lists. And this stuff just comes with practice, and over time, it becomes more intuitive and easier to understand. But definitely, my biggest advice to you guys for starting Python is just practice, toy with it, and find a project that you're passionate about, or do some programming. Maybe like write a neat program on like Python that inputs values and stores them in some way, and just have fun with it and practice with it. And over time, you get these easier, and it makes it it makes it more enjoyable and also better, and for you guys to grasp more intermediate concepts.
All right. And with that, thank you so much for coming today and staying and learning a lot more about Python. We hope you really enjoyed our first introduction to basics for Python workshop. And stay tuned, because our next workshop will also be coming up in 2 weeks on March 3rd at 7:30 p.m., in which we will be talking about data analytics with Python. So it'll be a little bit more advanced, but we will be using a lot of the same concepts that we learned today. So thank you so much for coming, and we hope you enjoyed and learned a lot.